Okay, so we know you've been thinking about settling space, like living on Mars and stuff.
Right.
And you're like us. You want to go deeper than just like the headlines and the,
Right.
the basic stuff, right? You want to know what it would really take.
Uh-huh.
And you want to do it quickly and, thoroughly without, it being boring, basically.
Exactly.
So that's what we're doing today. We're gonna do a deep dive into all that.
That's right. We read a bunch of stuff.
Yeah.
And for this one, A City on Mars by Kelly and Zach Weinersmith is where we're getting a lot of this.
Yeah.
And, when you first look at it, it's kind of surprising how plausible it seems.
Right.
We've got rockets getting bigger.
Yeah.
We know that Mars has, like, basic ingredients like frozen water and carbon dioxide.
Right.
So it doesn't seem impossible.
Okay, but here's the thing.
Yeah.
The Weinersmiths make this really good point.
Mm-hmm.
That when you go beyond just like the engineering and the raw materials and start talking about like people,
Yeah.
it gets a lot more difficult.
Yeah, it gets a lot more squishy.
So they use the word swishy.
Yeah.
And I love that word because it really does. It's like biology and law and
Yeah, and people being people.
yeah, human behavior.
Yeah.
And that's where it gets really tricky.
Mm-hmm.
So the big takeaway is that the engineering might be possible.
Yeah.
But the squishy stuff is where the huge roadblocks are.
Exactly. So, and that's what we're going to unpack today.
Right. That's what we're going to talk about.
We're going to go beyond the rockets and the cool, the basic stuff.
Yeah.
And talk about, like, what would it really take for people to not just get to Mars, but, like, live there
Right.
for a long time.
And thrive and reproduce.
Yeah. And just survive.
Right.
Like, how do we actually stay there?
Yeah.
Not just visit,
Right.
but stay there.
So speaking of thriving,
Yeah.
one of the first things they talk about is space babies, which is not something you think about right away.
No.
It
sounds kind of funny at first.
Yeah, it's like a joke, but then you realize, like, wait,
Yeah.
if you're going to settle space, you're going to have to reproduce.
Yeah. And a lot of the proposals just kind of assume that's going to happen.
Right, they just gloss over it.
Yeah.
And they use this great example of Space Life Origin,
Mm-hmm.
this company that wanted to have the first space birth by 2024.
Right.
And then their CEO quit because he said, like,
Yeah, he cited all these, like, ethical and
serious ethical safety
and medical concerns,
Right.
which is like a big red flag.
Yeah, like, maybe we shouldn't just assume this is going to be easy.
Yeah.
Yeah.
And then when you look at the data,
Uh-huh.
it's really limited.
It's really limited, yeah.
I think they said that only 5 NASA astronauts have spent more than 9 months in space.
That's right, yeah, 9 consecutive months.
And only 2 of those were women. And obviously none of them were pregnant.
Yeah, so we don't really know
Yeah.
what would happen.
Yeah, and that's a problem, right?
To a pregnant woman?
Yeah, to a developing fetus.
Yeah.
And, even if you just think about, like, the health risks for the mom,
Yeah.
you're talking about, like, bone loss every month.
Right.
Strenuous exercise that you have to do.
Right, in a challenging atmosphere.
Yeah, gravity is different.
Yeah.
Atmosphere is different. It's just...
Yeah, it's a challenge.
Yeah.
And it's not just about, like, birthing the babies.
Right.
It's like those babies have to grow up.
Right. They got to be healthy.
And then
They got to make more
have to
babies.
reproduce.
Yeah.
And so,
And you're talking about, decades to figure that out.
right.
Yeah.
Even if we're okay with some pretty
Yeah, a little-
unethical
Like pretty unethical experimentation.
experimenting on people.
Which hopefully we're not.
Hopefully not.
Right.
Yeah, so it's a much bigger problem than just like,
Right. It's not just diapers.
yeah, bringing diapers to space.
Yeah. Okay, so... And this is a good example of why we do a deep dive, right? Because you think, oh, space babies, no problem.
Yeah.
We'll figure it out.
Easy.
But it's actually like, oh, no, this is actually really complicated.
Right.
Yeah.
Okay, so let's move from biology to law.
Okay.
Because space law is another thing that people don't think about
Yeah, you don't really think about it.
when it comes to settlements.
No.
And I have to admit, when I first started thinking about it, I pictured like something from Star Trek.
Right.
Like some weird future law.
Right.
But it turns out there are actual space lawyers.
Yeah. There are real space lawyers.
And they're like scholars of international law.
Right.
And they work on this stuff.
Yeah, and the basic idea of space law is that space is like the ocean.
Right.
It's a commons. It belongs to everyone.
Yeah, nobody can claim it.
You can't just say, like, I own the moon.
Yeah. That's not allowed. No, you can't do that.
But here's where it gets tricky.
Okay.
The Weinersmiths point out that
Yeah.
Like, you can't own territory in space,
Right.
but you can use the surface.
Yes. You can use as much of it as you want as long as you don't say you own it.
Right.
So,
Like, how does that even work?
yeah, like how do you even
Yeah.
They actually give this funny example. They're like, you could theoretically write, "The moon belongs to the Wienersmiths, you filthy earth scum," on the surface of the moon. Like in giant letters.
Yeah.
And as long as you didn't like actually file paperwork to claim the territory, you'd probably be fine.
Oh, my God.
It's just like kind of a loophole.
It's a giant loophole.
Yeah, it's a huge loophole.
And it just seems like it's like a recipe for chaos.
Yeah, they think that.
You know?
So space is a commons, so nobody owns it,
Yeah.
but nobody really regulates what you do on the surface of it.
Right.
So it's kind of a free-for-all.
And we have this old space law.
Yeah, it's like an old document that doesn't really account for all the new technology.
Yeah. And all the new players.
Yeah, and the new geopolitics, and so they're like, this is going to cause a crisis.
Yeah. They think there's going to be some sort of crisis.
Yeah.
At some point.
So that leads us to another thing that people don't always think about,
Right.
which is like the geopolitics of it.
Mm-hmm.
Like the competition between nations.
Yeah. The if China does it mentality.
Yes. If China does it, we have to do it too.
Yeah.
And they use the example of helium-3 mining on the moon,
Mm-hmm.
which, for those who don't know, helium-3 is this,
It's an isotope of helium.
right, that could
Yeah.
potentially be used in fusion reactors
Right.
in the future.
Someday. We're not quite there yet.
But they're like, it's actually not even a good idea.
Oh, they think it's kind of silly.
Yeah, they're like, it's dumb.
Yeah, they talked to a bunch of experts on it.
Yeah.
They were like, this is not going to work.
Right. But everybody's doing it because
Yeah, because if China does it,
they're afraid of China doing it.
we have to do it too.
And it's not just like speculation.
Yeah.
They even quote NASA Administrator Bill Nelson.
Yeah, from 2022. He's worried about China making exclusive zones on the moon.
Yeah. So this is like a real thing.
Yeah, it's not just theoretical. It's like people are actually worried about this.
Yeah, and it just shows how these like national anxieties
Right.
can kind of drive space policy in a way that's not
That doesn't make sense.
not logical.
Yeah.
And it's not just that, right?
Mhm.
It's also like they don't think that going to space is going to solve all of Earth's problems,
No,
like climate change or resource scarcity,
you don't think so.
right?
They think those problems need to be solved here.
Yeah.
Yeah.
And they point out that like there are all these technological and scientific and legal hurdles
That we need to figure out.
that we have to overcome
Yeah.
before we just like jump into space.
Yeah, and they're worried about, like, if we rush it,
Yeah.
we could have, like, nuclear powers fighting over territory on Mars.
Yeah.
That's not good.
Yeah, that's not a good outcome.
So they advocate for this wait and go big strategy,
Mm-hmm.
which is like,
Wait for the tech to catch up?
let's research.
Yeah.
Let's make sure we have the right technology,
Mm-hmm.
the right science, the right law.
And then go big.
Right. And then when we do it big.
Yeah.
But it's not just sitting around waiting.
All right.
It's like
It's active research.
active research and development.
Mm-hmm.
And they give these great examples of, like, the kinds of things we need to research.
Right.
Like spider bots on the moon.
Yeah, little robots crawling around.
Yeah.
Doing stuff.
Figuring out how to make babies in Martian gravity.
Yeah, like a pregnadrome.
The pregnadrome.
Right, which is such a funny word.
Yeah.
And figuring out, like, what's the minimum population size for a healthy colony?
Right.
Yeah.
These are all things we don't know.
Yeah, we don't know.
And they even say it themselves. They're like, this is objectively awesome and bizarre.
Like, it's both awesome and bizarre,
Yeah,
but it's the kind of stuff we need to be thinking about.
exactly.
Okay, so
Yeah.
now they also address these common arguments
Mm-hmm.
that people make about, like, why we need to go to space
Yeah.
now, like,
Yeah.
right away.
Yeah,
So one of them is that, like, going to space will save the environment.
right.
Like, we'll move industry off-world
Yeah,
and
and that'll clean up the earth.
yeah.
Yeah.
But they're like,
They're like, no.
it's not that simple.
No, it's not that simple.
Because, like, just to keep up with the population growth on Earth,
Yeah, like 80 million people every year.
80 million people a year,
Yeah.
we would have to launch 220,000 people into space every day.
Every day just to stay even.
Yeah,
Yeah.
which is just not feasible.
Hmm.
And another one is that
Yeah.
that going to space will make us richer and more peaceful.
Oh, yeah. That one.
Yeah,
Because we'll have more resources so we won't fight over them.
right.
Yeah.
But there are, like, history shows that's not really true.
Yeah, they look at the history of war
Yeah.
and they're like, it's not about scarcity. It's about, like,
It's about religion.
religion
Yeah.
and bad leaders and
Yeah. And just misunderstanding.
misunderstandings. Yeah.
And so,
So more resources won't necessarily fix that,
Right. Just having more stuff doesn't make you more peaceful.
No, it doesn't.
And then there's the argument that, like, we just have this, like, natural human urge to explore.
Yeah, that it's in our DNA
Yeah.
to go to new places.
Right.
Yeah.
And they even quote Carl Sagan.
Yeah, the open road still softly calls.
Yeah.
Yeah, it's a beautiful line.
But they point out that, like, a
Yeah.
lot of human migration has been driven by, like, hardship.
Problems.
Yeah.
Yeah.
Not just, like, a desire to see new place.
Like war and famine and persecution.
Right. And they're like,
Like-
and also, like,
If we're not going to space, are we stagnating?
where is all the stagnation?
Right. Like, look at all the advancements we've made.
Since we, like, finished exploring Earth. Yeah, since we mapped the entire planet.
We haven't just stopped doing stuff.
Right. We've
Yeah.
invented so many things.
Yeah, we've invented computers and the internet and
Yeah.
like all this amazing technology.
And then the last one is that, like,
Mm-hmm.
going to space will unify humanity.
Yeah, we'll all work together.
Right. Like
Yeah.
on the ISS.
Right.
But they point out that, like,
But then they point out that like the head of the Russian Space Agency and Scott Kelly were like arguing on Twitter
yeah, after the invasion of Ukraine.
right after Ukraine.
Yeah, so that doesn't seem very unifying.
Not really.
So their point is that, like,
Cooperation in space is more of a reflection of like what's happening on Earth.
Right.
It's not like a cause of peace. It's a result of peace.
right, if we're already getting along, we'll get along in space too. But if we're not.
It's not going to magically fix things.
Right.
Yeah.
Okay, so now let's talk about, like,
Yeah.
the actual dangers of space. Like, what would it actually be like to live in that environment?
Yeah, it's a pretty hostile place
Yeah.
for humans.
So let's start with the vacuum.
Okay.
Like, no air,
Yeah.
zero pressure.
And they give this analogy, which I think is really helpful.
Okay.
They compare our bodies to like a sealed can of soda.
Yeah.
And if you open that can of soda,
Yeah, all the gas comes out.
all the gas comes rushing out.
Right.
And that's kind of what would happen to your blood
Right.
if you were suddenly exposed to the vacuum of space.
Because all the nitrogen in our blood
Yeah, the nitrogen that's dissolved in your blood
would form bubbles.
would form bubbles.
And
Yeah.
that's really bad.
Yeah, it's called decompression sickness
Right.
or the bends,
Yeah, the bends or the
Yeah.
chokes or the
Yeah.
staggers.
depending on where the bubbles form.
Right.
Yeah.
And then there's radiation,
Yeah.
which is a big one.
Yeah, we have the atmosphere here on Earth
Yeah.
and the magnetic field that protects us.
Yeah. We're lucky.
Yeah, we are.
But in space,
In space, you're exposed
it's a whole different story.
to all kinds of radiation.
Right.
Yeah, from the sun and from like deep space.
Right. Cosmic rays.
Galactic cosmic rays,
Mhm.
which are like super high energy particles.
And it's not like you're going to get hit by a death ray or anything.
No, it's not like that.
But it's like the constant exposure
The long-term exposure
is what's dangerous.
can cause cancer.
Yeah. And other health problems.
Yeah,
So how do we protect ourselves from that?
that's the question, right?
Yeah.
Yeah.
So they said for short missions, like going back to the moon,
Right.
they basically just use the mass of the spacecraft as shielding.
Yeah. Just put as much stuff between you and the radiation as you can.
Right.
Yeah.
But that's not going to work for like a permanent settlement.
Yeah.
You need something better.
You need something more robust.
And they think the solution is going to be living underground.
Yeah, probably underground.
Yeah, using the soil or the rock as shielding.
Mm-hmm.
Yeah.
And even with that,
Mhm.
there are limits.
Yeah.
How much radiation you could be exposed to.
NASA has this rule, like 3% risk of exposure-induced death,
3%.
which sounds okay.
Yeah, it doesn't sound too bad.
But then when you realize that, like,
But then you realize that some people are more vulnerable
yeah,
and others.
it gets complicated.
Yeah, like women are more susceptible to certain types of cancer
Right.
from radiation.
So some people are saying, like, we
Yeah.
should only send men to Mars.
Yeah, like a no girls allowed rule.
Yeah,
Yeah.
which is obviously, like,
Yeah.
a whole other ethical can of worms.
It's all other issues.
And then there's microgravity.
Yeah, zero gravity.
Yeah.
Or close to zero gravity.
Which is, like,
It looks fun.
it looks fun.
You see astronauts floating around,
Yeah.
but it's actually really bad for you.
Yeah, it messes with your body.
Yeah, it messes with all kinds of stuff.
Like your bones and your muscles.
Yeah, bone loss
Muscle atrophy.
and your vision.
Problems.
Because the fluids in your body shift around.
Yeah.
Yeah, they don't know where to go.
And the problem is that
Hmm.
most of our data comes from people in like
Is zero G.
0G on the ISS.
Yeah.
But when we talk about settling the moon or Mars,
Right.
we're talking about like
Partial gravity.
partial gravity or like
Mhm.
artificial gravity on a spinning space station.
Yeah.
And we don't know what that would do to the human body long term.
Yeah, especially for kids who are still growing.
Yeah.
Yeah.
So that's a big unknown.
Yeah.
And right now the only solutions we have are like
Diet and exercise.
Diet and exercise.
Yeah, lots of exercise.
Like 2.5 hours a day.
2.5 hours every day.
6 days a week
Yeah,
of strenuous exercise.
which is hard enough on Earth.
Yeah, and it's even harder in space.
Yeah, and you're more likely to get injured.
Yeah.
Yeah.
And then there's vision problems.
A lot of astronauts come back with, like, farsightedness.
Right.
Yeah.
And they have to wear these special glasses.
Space anticipation glass.
Space anticipation glasses.
Yeah.
And then there's even like,
And then there's, like, the cognitive stuff.
yeah, like brain stuff.
Yeah, we don't know what microgravity does to your brain long term.
And that's scary.
Yeah, it's a little scary.
Yeah.
Yeah.
So space medicine is going to be a whole other challenge.
Yeah, this could be a whole field.
Because even like trauma care
Yeah.
is different in space.
Yeah, like surgery's really hard.
Yeah, because the blood doesn't flow the same way.
Yeah, it just floats around.
Yeah.
Yeah.
So they're talking about like trauma pods
Trauma pod.
and special surgical workstations
Yeah.
designed for zero-G. So now let's talk about something that's on everybody's mind.
Okay.
But nobody wants to talk about
Yeah.
sex in space
Yeah.
and space babies.
Right.
Like, how do you even do
Yes.
that?
Yeah, the mechanics of it are
Yeah.
a little tricky.
They talk about all these like
Yeah.
proposed solutions.
It's like special suits
You're just
and
like a snuggle tunnel.
a snuggle tunnel.
And this thing called a two-suit.
A two-suit?
Yeah. And then there's this like 1970s concept for a space Chevy van.
A space Chevy van.
Blast. But
Yeah.
beyond like the mechanics of it,
Yeah.
there's the biology of it.
Yeah, like what does radiation do to sperm and egg cells?
Right.
And what does microgravity do to a developing fetus?
Yeah.
Like, we don't know.
We don't know.
We don't know if a baby needs gravity to develop properly.
Right. And the animal studies that they've done in space
Yeah.
have shown some pretty disturbing results.
Yeah, there were a lot of problems.
Yeah, like birth defects and
Yeah, and the babies didn't bond with their mothers.
yeah, and problems with bonding. And
Yeah.
so they talk about this idea of like
A pregnadrome.
a pregnadrome where pregnant women would go on these centrifuge rides
Yeah.
to simulate gravity,
Yeah.
which sounds
Sounds kind of crazy.
crazy and dangerous.
Yeah, and probably not very effective.
Yeah.
Yeah.
So the takeaway here is that
Yeah.
we really shouldn't be trying to make babies in space.
Yeah, not yet.
Not yet.
Not until we know more.
Yeah, until we have more data.
Yeah.
Okay, so now let's talk about psychology.
Okay.
Like, what's it going to do to our minds
Yeah.
to live in space for a long time?
Yeah.
And everybody always talks about space madness,
Right.
but
They don't think that's really a thing.
they don't think it's real.
No.
They think it's more of a myth
Yeah.
because, like, people have lived in isolated environments before.
Yeah, like in submarines.
Yeah, submarines and Antarctic bases.
Yeah.
And they haven't all gone crazy.
Yeah, they've done okay.
Yeah.
Yeah.
But it's still going to be tough.
Oh, yeah, it is going to be tough.
It's just you're going to be, like, living in these cramped quarters.
Yeah, with the same people
Yeah.
all the time.
Doing the same chores.
Yeah, eating the same food.
Yeah, the same food and the same clothes.
the same clothes
Yeah.
and like floating debris everywhere.
And noise.
Yeah.
And
Yeah.
it's not going to be pleasant. And they use the ISS as an example.
Yeah, it's like 2 apartments.
Yeah, for 6 people,
Yeah.
which is not a lot of space.
No.
And right now we have these like really rigorous psychological screening processes
Yeah, for astronauts.
for astronauts.
Well,
But those might not work for like
yeah, for regular people.
regular people.
Yeah.
And they used the Mars One program as an example,
Right.
which was like a disaster.
Yeah.
But it showed that like people are willing to go,
Yeah.
even if it's a one-way trip.
Even if they can't come back.
Yeah. So we need to figure out how to keep people sane.
Yeah, how to keep them mentally healthy
Yeah.
in space.
In space. Yeah.
And they talk about some of the things that might help.
Yeah, like in space farming.
Yeah, like growing plants
Yeah.
and listening to nature sounds
Yeah.
like birds and stuff.
Yeah, they said the cosmonauts loved that.
Really?
Yeah.
So it's not all bad.
No, it's not all bad.
But it's not going to be easy?
No, it's not going to be a walk in the park. So they're like, we need to do more research
Yeah, more research.
into space psychology.
Yeah.
So where should we go first if
Yeah.
we're going to settle space?
Yeah.
The Wiener Smiths take a look at the moon,
Yeah.
which they call a cosmic day trip,
Yeah.
compared to Mars,
Compared to Mars, yeah.
which is like
It's closer.
closer,
Yeah.
easier to get to.
You can get back quicker if something goes wrong.
Yeah.
Yeah.
And the communication delay is only like a second,
Yeah. 1 second.
which is a big deal.
Huge
Yeah.
if you're having an emergency.
Yeah, you don't want to be waiting like 20 minutes
Yeah.
for a message to get back to Earth.
And they also talk about lunar lava tubes, which
Yeah.
were these like
Giant underground caves.
giant underground caves
Yeah.
that were formed by ancient lava flows.
Millions of years ago.
Yeah. And they could be huge.
Yeah.
And they could provide like natural radiation shielding.
Yeah. And protection from the temperature extremes.
Yeah.
And some of them might even have like Earth-like temperatures. So they're
Yeah.
like, maybe we could just like
Move right in.
move into a lava tube.
Yeah. But there's a downside.
Yeah.
The resources on the moon are limited.
Yeah, like water ice.
Yeah, water ice.
Which is like the most important thing.
Yeah, we need that.
Yeah.
Yeah.
And they're like, it's not that much.
Oh, it's like a small lake.
A small lake.
Yeah.
So that could lead to conflict.
Yeah, if everybody wants the same water ice.
Yeah.
Yeah.
Okay, so what about Mars?
Okay, Mars.
Yeah.
Mars is a lot more challenging.
In a lot
of ways, yeah.
Yeah.
The soil is poisonous.
Yeah, it has these perchlorates.
Chlorates, yeah, which mess with your thyroid.
Yeah, and that's especially bad for kids.
Yeah, for developing kids.
Right.
Yeah.
And the dust is like this fine, jagged stuff.
Yeah, it gets everywhere.
Yeah.
Yeah.
And it's not good to breathe.
No.
And the sunlight is.